For centuries, humanity has gazed at the stars, searching the skies for answers. We've crafted theories, formulated equations, and imagined our place in the vast cosmic puzzle. But all of that, our physics, our cosmology, and our understanding of space and time, has just been fundamentally challenged. The James Webb Space Telescope has observed phenomena that, according to everything we believed, should not exist. It has discovered galaxies that appear far too ancient, planets too massive and distant, structures too flawlessly ordered, and even a steady rhythmic signal that defies all known astrophysical explanations. This isn't merely another scientific breakthrough. It's a direct collision between our accepted models and the observable reality. What Webb has captured could be the most profound message and warning in the history of science. If these observations are real, then much of what we thought we understood about the universe is deeply flawed, perhaps entirely wrong. In a series of unprecedented deep-field observations, the James Webb Space Telescope delivered some of the most detailed images of the cosmos ever recorded. But the significance of these images goes far beyond their visual beauty. In the galaxy cluster AEL 2744, researchers identified perfectly aligned points of light and symmetrical formations, patterns that should not appear in the chaotic, turbulent processes of galactic evolution. In the spiral galaxy NGC 1365, unexpected, motion patterns emerged, suggesting gravitational behaviors that run contrary to our most fundamental theories. These weren't isolated anomalies. The deeper Webb peered into space, the more unusual the universe seemed. Patterns began repeating across vast stretches of space. Structures emerged with stunning geometric accuracy in a cosmos supposedly driven by randomness. Scientists initially tried to dismiss these phenomena as coincidences, but their frequency, precision, and scale defied such explanations. Gradually, the question began to shift. What if what we're witnessing isn't randomness at all, but an unfamiliar kind of order? One of Webb's most astonishing observations centered on the exoplanet HIP 65426b, located hundreds of light-years from Earth. What it revealed left astronomers in shock. This planet, 7 times the mass of Jupiter, orbits its star at a distance 3 times farther than Neptune orbits our Sun. Even more puzzling is that the star it orbits is just 15 million years old, far too young, according to current theories, to host a planet of such scale and distance. No visible protoplanetary disk, no remnant debris, and no known gravitational mechanism can explain how such a massive planet formed so far from its host and remained in stable orbit. Some researchers now propose a radical possibility. This planet might not have originated in its current system. Could it be a remnant of a previous star system, somehow transferred, reused, or even deliberately placed? As of now, no answers exist. Only a glowing planet, suspended in a young system that defies all known models. In one of the telescope's most surreal revelations, it captured a nearly perfect Einstein ring, an effect caused by gravitational lensing, where a massive foreground object bends the light from a background source. This particular ring, found around galaxy J418, is almost a flawless circle. Such precision demands an exact alignment between 2 galaxies, accurate to within fractions of a degree across billions of light-years. This isn't just rare, it's statistically improbable. While gravitational lensing is well understood, the degree of perfection here suggests something far more complex. Could this symmetry be a clue to a deeper geometric order within space-time itself, an indication that the cosmos is not as chaotic as we've believed, but shaped by a hidden framework that we are only beginning to detect? No discovery has shaken cosmology more than what Webb has found regarding ancient galaxies. The telescope detected massive, mature galaxies forming just 180 million years after the supposed Big Bang, a blink of an eye on a cosmic scale. According to current models, galaxies of that size and organization should not have had time to form. They shouldn't be fully developed or exhibit the spiral structures and luminosity that Webb recorded. These findings have sent cosmologists into disarray. If these galaxies truly are as ancient as they appear, then the foundational theory of the Big Bang may no longer be tenable. Some researchers now openly admit that we might be observing evidence of a universe with a hidden history, events and formations that occurred long before what we considered the beginning. In an empty region of space, far from any known galaxy, Webb detected another anomaly, a gravitational lens effect occurring in a void. There were no stars, no galaxies, no black holes, nothing that should be bending light. Yet the light from distant galaxies curved and distorted as if something massive were hidden there. Astronomers attributed it to dark matter, the invisible substance that exerts gravitational force, but even that theory was pushed to its limits. The distortion was too sharp, too localized. It didn't behave like a diffuse cloud of dark matter, but instead resembled a structured mass with edges and symmetry. Could this be a condensed cluster of dark matter? Or is it something else entirely, an ancient structure, invisible yet powerful, continuing to warp space in eerie silence? Some physicists now entertain a more radical hypothesis. Perhaps it's not dark matter at all, but evidence of something built, something alien, something left behind. Among the telescope's most controversial findings is a massive intergalactic filament, a colossal alignment of galaxies and matter stretching over 1 billion light-years. Scientists have seen filaments before, part of the known cosmic web, but this one is fundamentally different. Its symmetry, density, and the repeating voids between galaxies suggest not a random formation, but something more organized. It resembles a grid, almost as if it were a framework laid intentionally across the universe. While conventional cosmology argues that such formations emerge from gravitational forces over immense timespans, the degree of order here is too precise to dismiss. Galaxies within the structure move along parallel trajectories. Dark matter clumps appear at regular intervals. Even redshift measurements reveal wave-like regularity. To some, this hints at an underlying architecture. While some scientists remain cautious, warning that human minds are predisposed to see patterns, others argue that if any intelligence ever influenced the design of the cosmos, this is where we'd begin to see the traces. In investigating gravitational anomalies, a provocative idea is gaining traction. What if dark matter isn't just invisible mass, but also a medium of memory? Not information in the way we understand data, but something deeper, cosmic memory. Multiple Webb observations show galaxy clusters forming in ways that reflect older, distant structures, almost like echoes that repeat across the universe. What if dark matter preserves these gravitational imprints, influencing the creation of future structures based on past configurations? It's a hypothesis that sits at the intersection of physics and philosophy, implying that the universe may not only have a beginning, but also a memory. If true, every spiral galaxy, every void, every filament could be part of a much older, possibly deliberate design. Perhaps the most chilling revelation of all emerged from a deep field scan in a seemingly empty region of space. The telescope recorded a pattern of pulses, light fluctuations too consistent to be random and too faint to be from any known astronomical object. These signals didn't match pulsars, quasars, or any other known source. They pulsed at exact intervals and then stopped entirely. Initially suspected to be an equipment error or data processing glitch, the signals were run through multiple, independent systems. Yet the pattern persisted. There was no star, no nebula, not even a detectable heat signature, only a precisely timed flash in the dark. NASA has not issued any formal comment, but internally researchers are quietly asking a question that has haunted science for decades. What if it's a message? Not necessarily one meant to be interpreted, but simply to be noticed. And if that's the case, who or what was intended to see it? The James Webb Space Telescope was designed to look back in time, to peer through the distant layers of the cosmos and show us what the universe looked like billions of years ago. But in doing so, it may have revealed something far more profound. We may not be mere observers of a random cosmos, but participants in a system that is older, more intricate and more intentional than we ever imagined. Galaxies that should not exist, planets that contradict our models, signals without sources, and structures that hint at intelligence. This is not speculative fantasy. These are real, recorded phenomena that defy the frameworks upon which modern science rests. If the patterns are genuine, if the pulses are intentional, and if the universe does indeed retain a memory, then we must face a staggering possibility. We have never truly been alone, not in space, not in time, and perhaps not even in our thoughts. It's possible that what Webb has uncovered is not just a view into the early universe, but a message, encoded in its very structure, or a system that was always waiting for us to finally look closely. And now that we have, our understanding of the cosmos and of ourselves may be changed forever. So now we must ask, are these findings signs of something more, or are we simply projecting our own longing for meaning onto the vast silence of space? The truth may still be unfolding, and the next image from Webb might not just show us where we came from, but where we are